Good morning, Excel Geo. And what we have today is we're going to be working with spheres and sections. So we're still in 11.5. 11.5 we're going to really go into depth with. So the first thing I want to talk about before we get into spheres and section is I want to talk about the definition of a circle. And we went over that already this year. Now, what is the definition of a circle? Now, the definition of a circle, it is a set of all points in a plane equidistant from a given point. So it's a set of all points in a plane equidistant from a given point. Now, guys, the key word here is going to be plane. Okay, so they have to be in the same plane, okay? So that was what makes something a circle. So a set of all points in a plane equidistant from a given point. And what's that point that we're talking about, that given point? That given point is our center. All right, guys? Now, what makes that different from what the definition of a sphere is? Well, a sphere is very similar in the definition. However, when we talk about a sphere is a set of all points equidistant from a given point. But it does not have to be in the same plane. So when I talk about a sphere, it's a set of all points equidistant from a given point. And again, that given point will be the center. But the key thing here is the points do not have to be coplanar. The points do not have to be coplanar. And that is the big difference between the definition of a sphere as opposed to a circle. So they do not have to be coplanar. And that's the one thing I want us to remember when we talk about a sphere. All right, guys? Well, one of the few things. So let's take a look at this now. So there we go. All right, so now when we talk about solid and surface, again, now remember the surface is just the material that is around that sphere. So this would be a solid sphere, meaning it could have be filled in. A solid would maybe, like an example would be something that is not filled with air. So a baseball is filled with rubber bands. That would be a solid. As opposed to if I think of a surface, I would think of something that's hollow. A soccer ball would be more of the surface because the inside is filled with air. All right, guys, that's the difference between our solid and our surface. And that same concept applies to spheres as it did with prisms and pyramids and cones and cylinders. So what happens when planes and spheres intersect? So when you have a sphere, we have an object that's a ball, and it can be intersected by a plane. So a plane can intersect that sphere. All right. Now that intersection is going to be called a section. So when it gets intersected, that is going to be called a section. A section is a two-dimensional plane figure formed by a plane intersecting a three-dimensional object. So a section is a two-dimensional plane figure formed when a plane intersects a three-dimensional object. (3D) object. That is what a section is. So the key word I want you to know there is section. All right. So if we take a look at this, a plane can intersect a circle at a couple different, points. So the first thing it can intersect is a point. Now, if you take a look at this, the plane is tangent to the sphere and only intersects the sphere at one point. So this plane is tangent to the sphere. Okay, so that plane being tangent, it will only hit that circle at one point. All right, now that great circle is something different. What a great circle is, it's a specific circle here. So a great circle, key thing about a great circle, if you see right there, a great circle has to be a plane that intersects the center of the circle. So this plane intersects, it's a plane. If a plane intersects the center of the circle, a great circle is formed. A great circle is the section. Now, guys, the key thing here and the reason why they call it a great circle, it is the largest circle that can be formed when a plane intersects that circle. All right, guys, so any type of plane that intersects that center of the circle will form a great circle section. Now, the next one, it says a small circle. Now, how does that differ? A small circle is going to be any plane that intersects the circle to form a circle, and it does not go through the center. So a circle is a small circle if the plane does not intersect the center of the circle. So oops, let's get this color coded. So if a plane does not intersect the center of the circle, doesn't intersect the center, and it doesn't intersect the center of the circle, and then it's going to be called a small circle. The section will be a small circle. Oops. Hold up, guys. Let's see. It shrunk a little. All right, guys. So those are the three possible sections. So it could either intersect at a point, it could intersect at the great circle, or it can intersect at a small circle. So in that case, so obviously that small circle is occurring when it's forming a circle and it's not intersecting the center. All right, guys, those are the only three possibilities if the plane intersects the circle. Otherwise, you would have a plane that does not intersect the circle and they would have no common section or point. All right, guys? So now let's take a look at our next thing. Now, what I would like you guys to do is pause the video right now, try the practice problems right here, 1 through 4, and then we'll come back when you're done. All right, guys, so hopefully everyone paused the video. All right, guys, we're going to try answering these questions here. How does the definition of a sphere differ from the definition of a circle? So let's take a look at that, guys. How do they differ? The points equidistant from the center do not have to be coplanar. So the key thing is the points equidistant from the center do not have to be coplanar. Key thing. All right, in a circle, they have to be coplanar, but in a sphere, they do not have to be coplanar. So if we take a look at the second question, it says the intersection of a plane and a sphere is either a single point or a circle, because it could be a great circle or a small circle, but no matter what, it will be a circle. Multiple choice in 3. If you think of the Earth as a sphere, then the equator would be a great circle. Intersects the center of the circle, it would be a great circle, that section. Tell whether each figure below is an example of a sphere or solid. Now, remember, we talked about a sphere. A sphere is like the surface, the outer part. Now, a solid sphere will be, the inside will not be air, so it will be filled. So a table tennis ball has air inside, so that would be just a sphere. Now, if I thought of a peach, well, a peach is filled in with the fruit in the pit, so that would be a solid sphere. A beach ball filled with air, just a sphere. And a baseball, the baseball has an inside, so that's going to be a solid sphere. All right, guys, those are the differences. All right, guys, now what we're going to do is kind of think a little, okay? Think of a cylinder of cheese. If you slice the cheese, will every slice always be circular? Explain. Now think about it. Can we look at a cylinder and can we somehow cut it a different way? Now, if I draw my cheese, I'm going to draw my cheese, my cylinder cheese. Can I cut this cylinder in a different way so it is not a circle? And if we take a look at this, I can cut my cylinder, in this case, the way I drew it. If I drew it vertically, what would that slice of cheese look like? What shape would that slice of cheese be? It's no longer a circle. It would be a rectangle. So the answer here is it cheese, will it always be circular in a cylinder? No. So in a sphere, if we cut it, it will always be circular. But in a cylinder right here, if we cut it from the base to the base, we will form a rectangle. So our answer here would be no. If you slice the cylinder from the base to the base, the slice would be a rectangle. Okay, let's take a look at part B then. Suppose you make a cut into a perfect orange. So we have our perfect orange now. So this will be a little different. Now, a perfect orange means it's going to be a perfect sphere. Is it possible to make one straight cut and get anything but a circle? And that answer is absolutely not. If we cut it, we would either have a small circle up here. We could have a small circle. Or we could have a great circle in the middle. So those are the two observations. I could cut it anywhere and make a small circle or a great circle. So the answer there would be no. If you slice a sphere, you will always cut a great circle or a small circle. So if you cut it, no. If you cut a sphere, the section will always be a circle. All right. All right, guys. Now let's take a look at this activity. Now this activity, it says complete the following table by identifying possible sections created in each figure. Hint, think about the problems above. What I would like you to do now is stop this video. I want you to go to the video below it after this is done. And I want you to watch that video and think of possible sections that can be formed when we cut a sphere, cylinder, pyramid, prism, and cone in different ways. All right. Not all the examples are in the video, but you might be able to use the knowledge from those examples to help you identify other possibilities for your surfaces here. All right, guys. So let's try that now.